Greetings guys, today we have a nice math problem for you today, and this problem occurred in 2012 May, paper 2 style question in higher level math problem, in the higher level math exam, and yeah, this problem weighs 9 points, and this is a calculus problem which concentrates on finding the expression for a volume of a cone. So let's get started. So first let's start with the question. A cone has a height h and a base radius r. Deduce the formula for the volume of this cone by rotating the triangular region enclosed by the line y equal to h minus h over r x and the coordinate axis through 2 pi about the y-axis. So, since we are asked to rotate through the y-axis, let's start by solving for x. So this would be the first step. So we have expression y equal to h minus h over rx. In order to keep things simple, we move h over rx to the left hand side and y to the right hand side in order to keep the sign positive. Then we just multiply by r on the both sides in order to get rid of r from the denominator. So we have hx equal to h minus y times r. Now we just divide by h in order to solve for x completely, and we get something like this: h minus y r times r over h. And in order to simplify this expression even further, we multiply by r within the parentheses, and we get hr minus yr over h. Now we can simplify h by dividing by h in both sides. So we have hr over h minus yr over h, and h, you see, crosses out, and we have x equal to r minus yr over h. And this is particularly simple expression, and it's very important to keep it simple because it just makes it easier to integrate for us. Alright, now the second step is integration. We have a volume. Expression for a volume is pi times the integral. In this case 0 to h, we have a base at the height 0 and h the total height. And then we have the expression that we solved just in the previous slide for x, and we square that and we integrate to the respect of y. So let's start by expanding the expression within the integral. So we have r squared minus 2y r squared over h plus y squared r squared over h squared. So just a simple expansion. And now we can start to integrate with respect to y. So we start by getting r here, r squared times y, minus 1 over 2 times 2 yr squared over h. Therefore the 2 crosses out and we end up with y squared r squared over h, just integration rules, plus 1/3, okay, 3 in the denominator, y cubed r squared over h squared. Alright, now the third step and the last step is to sort of evaluate the integral. So we just keep in mind, guys, keep the pi outside the brackets, and let's start to substitute h for y. So we get r squared h, we just plug h for y, minus h squared r squared over h, plus h cubed, again just plugging h for y, nothing fancy here, times r squared over 3h squared, minus, we plug a 0 for y now, and as you know the sign changes as you plug 0 in, so we have a minus r squared y, plus, as you know, when you evaluate the bottom, like a bottom value sort of, we always multiply by negative numbers, so we have minus plus minus. So we have r squared 0 plus 0 squared r squared over h minus y cubed r squared 3h squared. Okay? Now we simplify to keep things simple. We have pi again brackets, h is crosses out, so we have r squared h minus h r squared. These two guys can cross out now. We have 1/3, we have h squared and h cubed crosses out, and we have 1/3 hr squared minus 0 plus 0 minus 0. And the last step, all of this also crosses out, and we end up with a simple expression which is pi times 1/3 hr squared, and we conclude that volume of a cone when rotated through a y-axis of a height 0 to h, the expression for that is 1/3 hr squared pi. So this sort of concludes our video today, and I really hope you found this particularly interesting. And guys, if you want more videos, please comment, rate, subscribe for more videos. And if you have particular questions, just leave a comment below. I'm gonna be more than happy to answer the questions. And yeah, if you have any particular questions that you want to review throughout the if you want to see it reviewed, just please send it to my email. I'm gonna be more than happy to help you guys. And yeah, thank you for watching, and I'll see you in the next video.